Martin and Fabio. Martin is the lead of AI, and Fabio is a lead developer also at Samasource. So, Martin, Fabio, do you have any opening words you would like to start us off with?
I'm sorry, you're breaking up a little bit.
Oh, I don't think we can hear you.
Uh, well, I can see my microphone working here, but
I can hear Fabio.
okay.
Yeah.
Yeah. Alex, his audio was was breaking up a little bit when he was talking to, so I didn't get the last part that he yes.
Mistake, sorry.
I think you're good now, Alex.
But
Okay, cool. Yeah, I was just wondering if you had any opening words that you would like to share with us. Maybe like present yourselves, and then we can get started off with a couple Q&A question.
okay. Well, I'm Fabio. I'm one of the tech leads at Samasource, and I'm technical lead for the team that handles most of the back endes things of our platform, and including all the data ingestion and also the delivering the annotations that our agents make to the client's data to the clients. So a lot of data pre and post processing and handling the the workings of our big application. And I'll pass it over to Martine so she can introduce herself. But one thing that I'd like to talk about Samasource is that we are technically a rather large company. We have a few thousand people working for us because of all the agents that do the bulk of the work annotating client data. But our development and engineering side is actually pretty small and tight knit, and has a startup feel with about 15 people working on developing and keeping our digital platform running. So yeah, we are big and small at the same time. Okay, Martine.
Well, thanks for the introduction to the company, Fabio. This is truly appreciated. So I am I'm the lead of AI. So what does that mean? It means that I'm actually in charge of developing machine learning solutions to problems that we have internally mostly. So the idea is that we want to use machine learning to accelerate annotation of the data, which is essentially machine learning for machine learning, because our bread and butter is essentially we do data annotation for large clients, amongst which we have some of the biggest tech clients in the industry. So Google, Facebook, for instance, are some of our clients. And so we do a lot of data annotation, data labeling, but we to stay on top of our game, we need to make this as efficient as possible. And so we want to leverage machine learning to do that. So to do semi-automated annotation or fully automated annotation, automated Q&A, and so on. So basically, that's what I'm working on, mostly in computer vision. We have a small team here in Montreal. There's about four permanent members of the machine learning team right now, but it's growing, and we also have some other members of other teams that have joined us on a temporary basis to help us grow faster. So so yeah, that's it. You can fire your questions now.
So I'll start off with one, Martin. So you mentioned that your machine learning product is for the sake of better annotation. So is it kind of like there's two layers of machine learning, in that your tool is helping build the data sets that your Samasource is then sending to other companies to build models off of?
Absolutely. And so clients, usually the clients that we have right now, they come with tons of data. And this data can come in various formats, mostly images for sure. This is our big sector, say, with computer vision. But we also have point clouds and various other computer vision related sort of data that we receive. And the clients, they want this data to be annotated, to be labeled. So, and these labeling tasks can vary. There is, of course, a simple classification. So you just need to say whatever you see on the image. You need to give it a label. Or it could be more complicated, like literally drawing polygons around regions of interests, bounding boxes for training object detectors. So there's a whole bunch of computer vision tasks that labeling tasks that we need to perform for them to train their models. But yes, you're absolutely right. What we are trying to do internally is to build machine learning solutions to help the annotation process and not to send the model to the clients, right? So this is really what we're focusing on.
Awesome, thank you.
Don't go all at the same time.
So here we actually have a couple more questions in the Q&A. So Katie asked, can you describe your day-to-day responsibilities a little bit more?
Oh, sure. Fabio, you want to go? You want to start with your daily responsibilities?
Okay, my day-to-day. Well, first there is a little bit of actual development. I do get time to write, to code myself, and plus design and thinking ahead on how things are going to look like. But as one of the tech leads, I'm also in meetings with our product managers to think about what we're going to be building next. Next meaning next sprint, meaning next month, next quarter, sometimes even throughout next year. So there is a little bit of administration on keeping the team running and everyone busy. This is pretty general. If we're looking at a more specific answer, please be more specific about what, if you're interested about specific projects that we might be working on, please do a follow-up question. But I'll leave some time for Martine to talk to.
So I have the glamorous job. Essentially, I'm doing all the whiz bangs, the magic with respect to machine learning, which involves any number of things, from just looking at the ceiling, trying to figure out what the hell the most recent paper means and how can I apply it to some of the things that we're doing, because we have very interesting challenges internally. I also typical day I would code also, most probably some training pipeline to train a model, which involves anything from designing the architecture of the model to coding how we're going to ingest the data in a particular way and transform it and pre-process it so that it's amenable to training those interesting models that we want to cook up for targeting specific issues and problems. And I'm also involved in disseminating the results that we have from experiments that we're conducting internally. So writing papers, writing blogs, keeping on top of the literature, so reading a lot of papers also. Involved in also I was involved a lot in the development of the infrastructure for machine learning training and deployment, which was done, of course, with the help of members of Fabio's team, because I am by no means an expert in cloud and deployment and Kubernetes and such. Although, you know, I'm sort of like becoming a bit more accustomed with the jargon now. But certainly we needed help there. And what else? Meetings, lots of meetings, strategies, understanding where product is going, where they see themselves, and where they see machine learning have an impact on their deliverables. So yeah, there's tons. Like my week is a patchwork of very different and varied tasks. So it's quite interesting.
Awesome, thank you. So the next question from Linda is, what's the most popular programming language used in AI? And also for Fabio, what does Samasource use for its software development?
So I can answer the first question. This is a little bit of a no-brainer right now, because it's Python. It's inescapable. It comes with certain advantages, of course. Python is very easy to pick up and to start using. You can start using it in very wrongly, though. I mean, it's a language that is it's opinionated about a few things, but then there's so many ways you can tackle a certain problem, and so many inefficient ways you can tackle the problem, that it can be a mess, really, as a language. But it is the de facto standard right now. TensorFlow, PyTorch being the two main frameworks for developing machine learning solutions are completely intertwined with Python for the moment. I'm crossing my fingers, though, for emerging languages, and I would really encourage you to go and have a look at what's out there. For instance, I really am getting more and more interested. The community also is getting more and more interested into Julia. And Julia is a language that emerged from the MIT. It's a very scientific language that is a bit reminiscent of some of the best things of Fortran, but mixed up with some of the best things of Python. So it's got very interesting capabilities, and more people in the machine learning community and the AI community are seeing this as potentially an interesting language to replace Python in the future for machine learning. So yeah, but right now Python it is. What about you, Fabio?
Yeah, first let me chime in that I was sad when Torch moved from Lua to Python, because I have a big of a personal I'm a Lua fanboy, and a personal investment on the language. I was part of that community for a long time. But Julia is a great language, and has a lot of interesting stuff, not just from Fortran, but pulls a lot of stuff from Lisp and from Dylan, with another Lispish language. So it is very interesting, and check it out. On what we use, it is a lot more in parts a lot more boring. Our main app is a big Rails application. Rails, Redis, and Postgres, the bread and butter of web apps. But lately we've been, because this is straining under the load of our growth. We've been adding satellite services and doing more stuff lately using Go, and some things on the architecture and deployment side, with with Kubernetes and using stuff like that. Even a little bit of Lua, that is a part of the log processing of a service that we have, uses about a dozen lines of Lua, because it is the plugin language of the log processing that we use. So a mishmash.
Must have been you inserted that they do those 12 lines.
No, this was completely coincidental. It is the best tool for the job, and as a lot of tools, it uses Lua for its own internal scripting. So it was a nice coincidence. I didn't know it used that before I picked it. So
perfect, thank you. So Catherine is asking, how did you get into AI?
Oh my, that's like that's by accident. I was so I did a PhD in say theoretical and computational physics, so soft matter physics. I was studying biological systems, mostly cells, biomembranes, biopolymers like DNA and proteins. And so this really was my focus initially. But then I remember I did my first postdoc at the hospital, at the Ottawa hospital, and we were trying to automate a boring task that the lab was involved with, as they basically have to look at thousands of patterns, of swimming patterns of mice in what they call the Morris water maze, which is not a maze, by the way, but it's called the Morris water maze. It's essentially a little platform under a murky, milky white water, and you drop the mice in there, and they need to find the platform, and it's a test for memory and Alzheimer's, basically. So they use it a lot, the Morris water maze. And so they have to look at the pattern of swimming to characterize it, to sort of like see what the outcome of a drug or treatment or a genetic manipulation is. And so I said, well, maybe we can automate this using a neural network, which wasn't really such a great idea, but turns out that I sort of then I started looking at neural nets, and back then you had to build your own. So I built my own, and it was just a feed forward neural net, but it kind of worked. And I was like, well, this is cool, maybe one day I'll come back to this. But then there was no real job out there for like neural net stuff. It was just a fancy academic thing for me. So then I went on to work in other areas in the industry, but then it started. I was always keeping an eye on sort of like AI. I always found it to be interesting, machine learning, I should say, not necessarily AI. And then what happened in 2012? I mean, convolutional neural nets were like super, suddenly they became more interesting, with LeNet and GoogleNet and so on. People were like, oh my God, we can solve complicated computer vision tasks using convnets, and, we can train them ever more deeply. And so I decided to try. I registered for the very first semester of the Udacity sort of nano degree back then. They sort of like announced that. They said, we're going to do a nano degree. It was the first time. So I said, yeah, I'm going to register for that. And I was like, this is really great. TensorFlow was in its infancy. It was 0.4 or 0.42. I can't remember what version it was. So it was all in pure TensorFlow, which was a mess, by the way. And then I started applying for machine learning jobs, and I got in. And lo and behold, about 5 years later now, 5 years later, roughly speaking, I'm now here at Samasource doing machine learning, and I've done a whole bunch of different things, like from natural language processing initially, before BERT. So before the Albert, huge BERT, GPT-3s, and whatever huge language models out there, we were using much more modest means, like, little word vectors and so on. It was the good days, I would say, where it was not that costly actually to train a language model. But it wasn't that good either. and I went to do also computer vision in medical imaging, and now I'm doing computer vision at Samasource mostly. And so yeah, that was my to AI.
And for Fabio, how did you get software development and end up lead software engineer at Samasource?
Okay. Yeah, I would say that I'm not an AI or machine learning person, so the but so in software, I started studying computer science at late 90s, so I've been in this game for a long time, and before that, I was even before university, was a bit of a computer geek, and at the early 90s, being a computer geek mostly meant programming the computer that you had. I spent a few years before university toying with writing small programs and playing with it, and yeah. And so after university, I spent some time at grad school, although studying probably a lot less textile line of study with programming language design and implementation. So spent several years studying that, how you make the programming languages tick, and spent some time in academia, and after that, doing some research and teaching, and ended up back in industry after that, and I guess having a lot of experience handling students and handling working with other folks ends up teaching you one thing or two about working in teams and making teams run. So here I am.
Awesome, thank you. So John is asking, do you have any advice about where to start learning machine learning, or any suggestions for a beginner project?
Oh, do you have any advice about where to start learning machine learning? There's so many of these tutorials, and I mean, you can always. I find that stuff like on there's free classes, you know, like Andrew NG, I think, has this amazing class from Stanford. He started Coursera also, but there's a lot of free material to learn machine learning now. I think even Yann LeCun, which is like one of the biggest names out there, considered one of the fathers of machine learning, with Yoshua Bengio here in Montreal and Geoff Hinton in Toronto. Yann LeCun is at Facebook. He's the big machine, the big AI guy there. And I think he made his lessons freely available also. So Jan's lessons also, and they're very good. I've seen them. So that's also available. And then you can always register for one of those small programs, whether it be Coursera or the Nano degree is always interesting. Why? Because sometimes you just need to get somebody who sort of gives you a little kick in the butt to try to actually do the things, that the projects, try to take a model and try to make something out of it. So these are always good, and you know, they incentivize you in a sense to produce something, to put it out there, and to get it evaluated by somebody who will give you a grade. So these little nano degrees, or sort of on Udacity or on Udemy, are interesting for that. No, they get you going, and they force you to actually do the code and push it to GitHub and having it seen by somebody else. I know the course, the fast.ai, so fast AI, right? Fast.ai it's very interesting. Like it's led by a very interesting person also, and very passionate developer of tools around PyTorch. So they use PyTorch as a foundation, but Fast.ai is very interesting, and they have a very interesting course that is super hands-on, very pragmatic and practical solution in machine learning. So very interesting there. And I think that although the course needs registering, the repository of all the classes and all the exercises is freely available, and all the tools required to follow along the classes and the projects are also freely available. So there's no reason for not to have a look at it. You can always pick up a book. There's the now infamous 100-page machine learning book, which is actually not 100-page, but more like 140 pages. But still, it's a good introduction to get into, again, practical, pragmatic machine learning. And you can also get the very super theoretical book by Jan Goodfellow, Aaron Corville, and Yoshua Bengio, which is Deep Learning. I think it's really just called Deep Learning. It's a good book. It's got all the theoretical foundations for somebody who's more like mathematically inclined, for instance. You know, you want to dive into the mathematics of deep learning. Quite interesting. So these are some of my suggestions. Really, one of the I think you should also, one last suggestion, maybe you should have a look at Kaggle. Kaggle, if you want to learn machine learning, there's nothing like diving into a problem and trying to solve it. Like, I know for myself, I can read a lot of papers and so on, and it's interesting, and you can reproduce some results, and it's interesting. But having a data set, having a challenge, and having somebody tell you, well, I need to figure out where all the seals are on these rocks from satellite pictures, then you're like, oh, that's interesting. I need to count seal population. So that's a challenge then. And, you know, it's an example from Kaggle. And then you dive into it, and then you go read what the community is building, because it's a large community. People post their solutions or half solutions and so on, and there's a leaderboard, so it gets you like going, and you're like, yeah, I can have a better score if I do this. And then, you know, so it's an interesting place to learn, and there's tons of available data sets and challenges for you to try out if you go on Kaggle. So it's a good place to dive right in if you're more of the doer kind of personality, you know? So yeah.
Yep, awesome, thank you. So on a similar note, Linda asks, did the lack of a formal education in machine learning ever hinder you in your work or career? And did your physics education help you?
It certainly did not under me, because of the time, because of when I joined the community. At that time, about 5 years, it's not long ago, but about 5 years ago, there was a complete lack of talents, actually. So because the programs, what you know now from, say, the Mila, right, there is this professional masters in machine learning. So there's more and more students coming out with knowledge of machine learning, and now there's a bigger workforce available for the companies to hire from, so that they can get the talents to do what they want to do in machine learning. But back then there was absolutely nobody. So physicists, mathematicians, they're really still, even nowadays, I think that physicists, mathematicians, PhDs in computer science who have dabbled a little bit in machine learning, they're still very much in demand in machine learning and AI. So it's not something that hinders your career in terms of doing applied research, but it's something that would hinder a career in, say, more fundamental research. So let's say I'd be interested in joining later on in my life, you know, I want to join Google, or Google AI, or Google, what is it called again? Google Brain, right? OpenAI or FAIR, the Facebook AI lab, right? Somebody like me would probably have a little more trouble joining these teams as a fundamental researcher because I lack the formal training in the publication in the field to really make for an attractive candidacy from their point of view. I think the physics education. I mean, I know you guys probably won't change your degree to physics, but it has been tremendously helpful because, especially if you go beyond the bachelor's in physics and you start getting into research and you start getting into, in my case, computational research, so simulations and such. It was amazing. I got to have a strong enough theoretical foundation, so comfortable with mathematics, comfortable with, say, for deep learning and machine learning, it's linear algebra and optimization and calculus. Really, it's all mixed together. So if you know a bit of optimization, if you're comfortable with calculus, and if you're comfortable with linear algebra, you're fine. You're good to go. Deep learning is just that. Put those things together, and you'll get it. And yeah, physics was an amazing background to get to be comfortable in machine learning and AI. So again, not trying to convince you to change, but.
Awesome, thank you. So now a question for Fabio. What are some of the biggest challenges you face when you're dealing with building the Samasource platform and building the annotation service for the thousands of employees that you have?
I guess the biggest challenge is making making sure we want to get at the place where we want to get with the platform, to make the changes that we want to make to the platform and the additions that we want to make, in a way that we are always making progress to that goal, and you're not saying, no, I will spend months without any visible improvement, but trust me, at the end of that, you're going to get something good. It doesn't work like that. You have to go piece by piece to where you want to get, and to do that with limited resources. So use your resources wisely to get to move that big ship of code to where you want it to go. Change it a little by little. I've not been long at Samasource. I've been almost one year, and I inherited a mess, the end result of several years of development by a bunch of different people. And you have to rein in your impulse of oh, I'm gonna scrap a bunch of things and rewrite and do it my way. No, it doesn't work like that. You have to go and get the places where you want to put your leverage, and you get the best thing for the resources that you want to invest.
Awesome, thank you. So Alina asks, how do you keep on top of the new developments in the AI industry?
I'm not sure that's actually possible. It's more like it's a tidal wave of development on a daily basis. You must have like hundreds of submissions to archive, some of which might be super exciting, and some of which might be just incremental improvements to method XYZ. So it's really it's a huge challenge. You have to get your sources straight. There's a few places where they So first of all, I follow a few interesting individuals on Twitter. It turns out that scientists and machine learning in the machine learning community, they really like to tweet about whatever they do. So so by following a few key individuals, you get either their papers will surface or they will surface other interesting research in my Twitter feed. So that's interesting. I get a lot of papers out there. And also Papers with Code is amazing. They have like this paperswithcode.com, I think, is the website, and they have this trending and other labels where they sort of aggregate interesting papers, often with code, so that you can read the thing and then try it out if you're lucky and if it works out quite fine. So Papers with Code, and then of course there's Archive and Archive Sanity, I think, that Andrzej Karpati has put out, where you can sort of again tries to prune out all of the noise and dampen the noise and increase the signal, right, so that you can get the papers that are interesting. But it's really hard, to be quite honest, and sometimes you have to, and you can't read all of this. You read the abstract, you read the conclusion, you look at the figures, you look at the equations quickly, you're like, oh yeah, that looks interesting. You put it in a bin of, maybe I'll do this later on, or maybe I won't do it at all because it's just fancy research that looks interesting. And you have to do a little bit like Fabio says, you can't take all of this and try to implement it all. You have to be selective. You have to think about what is going to have the most positive impact on the organization, and is not going to be so costly in terms of resources, either human resources developing the solution, or even computational resources trying to train the algorithm or use it for inference, right? So if you use like super huge models and you require a huge graphics card that costs you $48 a day to deploy in the cloud, probably Loic, our VP, wouldn't really like me that much, actually, if I came up with a solution like this. So it's better to come up with solutions that cost less, right, and that are less hungry in resources, and but still manage us to tackle some of the interesting problems that we have. So yeah.
Perfect. So next question from Alex is, what are some of the most interesting real life problems, I guess, in your personal life that you've used machine learning to solve, for both of you?
In my personal life? At home, you mean? No. I don't use machine learning for any, unfortunately, for any personal projects. But at Samasource, I can give you an example right now. When I came in about a year ago, roughly at the same time as Fabio, we had nothing. We had absolutely nothing in terms of machine learning. It was brand new. And so we were looking for interesting problems to solve, and I was like, okay, so give me the more, so one of the most time-consuming tasks, and somebody said, well, it takes a long time to draw a polygon around those cars that we're doing for the autonomous driving industry. And so I was like, okay, so if it takes a long time to draw those polygons, maybe we can try to semi-automate it. And I had read some interesting stuff out there with respect to like few clicks annotation. So, instead of drawing the 20 points around the shape, say, what if you can actually draw the shape with, say, 4 points? And in this case, there was an interesting paper called Deep Extreme Cut, which I think was essentially 4 clicks, 4 extreme clicks around the shape. I'm not going to say it, Fabio, not the 4 clicks. Left, no, I'm going to say it: leftmost, rightmost, topmost, and bottommost points. I've repeated that frequently in some presentations at Samasource, so it's a little bit of a running gag. But anyway, so when you put those 4 clicks in with the image, we train the model with these 4 clicks in the image, and we train it to predict a mask, and then we convert that mask to sparse enough polygon that it resembles what a human would output in terms of drawing the same polygon shape. And so we developed this, we tested it out, we tried A/B testing it, we developed jointly with the front end team a set of tools that allows to interact with the model, and we deployed the model, and now it's we have the tool in production, and we've conducted more serious A/B testing recently, and we see amazing improvement in annotation efficiency for projects that involve lots of polygon drawing around cars, for instance. So that has been a very, I would say right now, I would say it has been the most successful machine learning project I have conducted to date. So quite interesting.
Awesome, thank you. So I think that's the last of the questions we have so far. So if anyone has any last questions, I'll give you a chance to ask. And if not, I just want to thank both Fabio and Martine for taking the time to chat today. And it was great hearing both of your experiences at Samasource and through your careers. So thank you for your time.
It's been a pleasure. Have fun hacking away your interesting solutions to the challenges that we've posed. I can't wait to see them.
Yeah. Thank you all for your time and your questions. It was fun, and have fun with your hackathon. When I was at school in the late 90s, we didn't have any, so I never actually participated in any of those. So enjoy.
Yeah, you're absolutely right. We didn't have any.
Thank you again. Have a great day.